Okay, okay, great. Again, nice to see everybody. I do hope you're all doing well. So, first things first to say is congratulations. You've already finished and learned everything you need to know about truth functional logic. So, woo! Good job, you guys. Now the real magic starts. So, what I want to do today, and this is the first of 3 lectures where we're going to talk about stuff relating to first order logic. What I want to do today is start off by talking to you about the very foundations of how this second formal language is going to work. And we're going to talk about, right at the beginning, a little bit of motivation for sliding into this new formal language. And the key notion, right? And the basic thought here is that, to spoil a joke that I'm going to make in like 3 slides, is we're going to split the atom effectively, right? So our basic unit in TFL was an atomic sentence, right? It was a capital letter. We didn't have any subsentential parts. We didn't have things like names or verbs or adjectives. We just had like a sentence was an immutable, cohesive object. And that's really useful for some things, but it was also a limited kind of restriction. It meant that we couldn't capture everything that we necessarily wanted to. And FOL is going to replace the base unit. So instead of just a capital letter with no constitutive parts, our new base unit is going to be a predicate and a term. So instead of just being a capital letter, our base unit is always going to be a capital letter and a lowercase letter. Now the type of lowercase letter we fill in here, we have 2 kinds. More on that in a second. But this is going to be our new base unit. And in that sense, it's actually closer to something like English, right? If you think about an English atomic sentence, you have a subject and a verb. Right? Or to put it a more broad way, you have the thing the sentence is about, and then you have some quality or way that the thing is. Right? What it might be doing, or what it's like, or how it stands in relation to other things. We're coming closer to the English in our formal language. It's still formal in that it's going to have a lot of restrictions, but it's closer to the English structure. So that's the core idea. And what I want to do is, again, the aim of this lecture is to try and get you in through that basic idea and talk about some initial first order logic symbolizations. So I want to talk through the building blocks, especially this first bit, the idea of terms and predicates. And then we'll turn to the second really big, powerful thing that first order logic has, which is how we can play around with terms. So that's what the quantifiers let us do. Quantifiers are ways for us to play around with spots where terms are filling in. And then once we have all of those, I want to talk you through some initial FOL symbolizations, so kind of mapping from English into first order logic. You know, the stuff that we did a couple weeks ago from going to English into TFL. And it'll be the same idea here. And I'm going to teach you 4 really broad, extremely useful first order logic symbolizations. How to say every F is G, some F is G, no F is G, and not all F's are G's. Don't stress. I'm going to talk you through those. Honestly, if we know how to do those 4, most of the FOL symbolizing we're ever going to want to do is done. It'll be versions of those 4, one way or the other. And we'll talk a little bit about the idea of paraphrasing and quantifier scope. I'd like to get through as much of this as we can. We'll see. And we'll finish by talking about the last big thing, which is basically splitting the atom and the notion of quantifiers together to give us talking about multi-place predicates and multiple quantifiers. And we'll finish off by talking about everybody loves somebody. Promise that'll make sense when we get there. So that's the plan. If we don't get through all of it, that's no worries because we can roll this. So basically the next 3 weeks are going to be talking through this first order logic stuff. Ideally, we'd like to try and get through all the grammar things this lecture and the next one to set us up then talk about in 2 weeks' time how to interpret FOL sentences. That is, when are they true and when are they false? But again, it's kind of working this through together. So you know the drill. Stop me if you have questions along the way. We'll figure this out. So let's get started with the building blocks of first order logic. And actually the place to start is a little bit of a motivation. So let's consider this argument. If we're just thinking about this argument, right, first thing to ask, is it valid? Yeah, I mean, it's valid, right? Socrates is human, all humans are mortal, so Socrates is mortal. Seems valid. Now, if we think about it, how would we symbolize this into TFL? Well, you get something like this, right? And the problem is, if we treat this as, feed that into our truth table machinery and look to see, hey, do the premises tautologically entail the conclusion? The answer is no. It's very easy to make the premises true and the conclusion false, right? Because we can make evaluation that just has H is true, M is true, and S is false. They're just atoms. An evaluation is a stipulation of truth value for atoms. So the problem is TFL tells us this argument is not valid. And that's bad because, again, to go back a slide, when we think about it in the English, it clearly is. So the problem is that TFL doesn't allow us to capture the structure that makes this argument, when we think about it in the English, actually make sure that the premises guarantee the conclusion. Because the structure here isn't at the level just of the sentences, it's at the parts of the sentences. It's the fact that we're talking about Socrates in the first premise and the conclusion, and we're using this predicate in both cases, in 1 and 2, and we're using this predicate in 2 and 3. We need subsentential parts. So what we're going to be able to do eventually is capture the argument. And here it is. Here's how it looks in first order logic. Right? We're going to have a premise that tells us Socrates is human. We'll have a premise that says, hey, everything, if it's human, then it's mortal. And then we basically feed A through, and we get, oh, A must be an M. Now, the thing to remember with this one, remember the very, very, very first argument we talked about in tutorial 1. And we talked about it in terms of Venn diagrams. That's all this says. This is just a way to symbolize a Venn diagram. Everything that's in this circle is also going to be in that circle. That's what this language is doing. It's just a way for us to express that idea. First order logic is going to allow us to capture the missing structure that TFL couldn't, and it does so by allowing us to talk not just about sentences, but subsentential parts. That's the big game. That's the big, 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 big game. And as soon as we have subsentential parts, names and predicates, or terms and predicates, we can do a whole lot more. Okay, so I'm going to throw out this right at the beginning. Here is what the language consists of. FOL consists of 6 kinds of symbols. If you remember, TFL only had 3 kinds. We have 6 kinds now. First, we're going to talk through these one by one, but I'm going to introduce them all together, right? First, we have terms, and there are 2 types of terms. There are names, and there are variables. Names we will express with lowercase letters, A through R. Variables will express with lowercase letters, S through Z. And as before, we can use little subscripts if we need to. Now, as well as the lowercase letters, we also have uppercase letters. Uppercase letters are predicates. Predicates we express with uppercase letters. They can have subscripts if we want. Predicates are basically going to conform to things like is mortal, is a horse, is in Tilburg, is Dutch. Right? Names are going to be things like Nathan, Tilburg. Right? Variables are, well, they're a bit like pronouns. We'll talk about them in a minute. Yes? Yeah, kind of. So predicates are basically ways of being. That's one way to think about it. And then names are the individuals we can slot in. Right? So Nathan is in Tilburg, right? Let's have capital T be is in Tilburg and little n be Nathan. TN is a way to say Nathan's in Tilburg. Okay, so again, the core, the new constitutive element, the base unit, our 1-1 Lego block, actually just isn't a Lego block anymore. It's got little tiny, smaller, angrier Legos that make it up. And the smaller, angrier Legos are always going to be a predicate and a term. Every FOL sentence has to have at least one predicate and at least one term. That's our new base unit. It's a combination of capital and lowercase letter. And on top of that, we have the connectives. They work just like they did before. Everything that you learned about the connectives with TFL applies for FOL too. So cool. And the same with brackets. The brackets work exactly like they did with TFL. Nothing new with either of these. The last part are the quantifiers. The quantifiers are functions, effectively. There's two. There's the existential and the universal. We'll talk about them as we come along. But the basic idea is that they let us either say something or everything. So there are ways to allow us to talk about collections of things rather than just single specific individuals. Again, we'll talk more about these in detail. I just want to introduce them to you in the very broadest terms. Okay. So that's what our language is going to consist of. Right? And now let's go through these one by one in some detail. In order to get a grip on terms, it's helpful to take a step back, think about philosophy of language for a second, and talk about terms in English. Right? And actually, not just in English, but we'll talk about English. This applies to Dutch as well. Right? So there are broadly two types of terms when we think about them in natural language. There are singular terms, which are words or phrases that pick out or refer to specific entities. And then there are general terms, which pick out something like kinds or types. So for example, Mira is a singular term that picks out my dog, and dog is a general term that picks out the type of thing that she is. Socrates is a singular term that picks out the dead Greek dude, and human is a general term that picks out the kind of thing he used to be. Again, basically a general term is a noun to let us pick out a kind or a type. Whereas a singular term is something that picks out a specific thing, one individual, one object, one entity. And if we think about singular terms actually come in at least two types. There are proper names, which pick out a specific entity without describing them in any way. So Mira, the fact that you know Mira is the name for my dog, well, just from that name alone, you don't know anything about her, right? You wouldn't know, in fact, if I told you, oh, Mira was on the couch when I left. You don't, strictly speaking, know anything at all about what she is, other than she's something that could be on couches, but that's not from the name. So proper names denote, refer, pick out specific entities without any kind of description. Contrast that with definite descriptions. These are singular terms that pick out specific entities, via a description that one and only one thing satisfies. The tallest person in the room. Right? That's a definite description. If it picks out anyone, it picks out exactly one person. I'll let you guys figure out who that happens to be. Right? It ain't me. Another way to get a grip on it. Socrates is a proper name. The teacher of Plato is a definite description. It applies to one and only one person. As it happens, these supposedly denote the same person. Okay, before we go on, do we get the difference on how proper names function and how definite descriptions function? Is that the kind of broad idea here? Yes?
Definite descriptions can be used to describe non-humans.
Absolutely, absolutely, right? I mean, the dog owned by Nathan is a definite description that picks out Mira, right? The university in the city of Tilburg picks out this university, right? The building we're in right now. All of these are definite descriptions, right? The fact that we're using individuals here is just easy ways in, right? The same thing with proper names, right? We can have proper names for non-human objects. Here's Steve, right? Welcome to Steve, right? Everybody welcome Steve to the class. That's the idea. Again, doesn't really matter what kind of thing we're talking about. Again, just the sort of way they function. They're all singular terms because if they work at all, they pick out one thing, but they seem to do it via different kinds of mechanisms. Now, we'll talk more about this in the second half of the class when we turn to thinking about philosophy of logic. But for now, it's useful to have this idea in the back of our heads. Okay? So, turning back to FOL. Well, in FOL, remember there's two types of terms, names and variables. Names are basically like proper names in English. That is, we're going to express them, as I've said, with lowercase letters, in particular A through R. We can have subscripts if we need them. They function like English proper names in that they just designate things. They don't tell us anything about what they designate. There's no descriptive content to it. But they're unlike English proper names in that there's absolutely no ambiguity. And what I mean by that is each name picks out exactly one thing. For any given name, it only is the name for one thing. Easier to think about this. How many people do you know named John? Or Jan, if you like that better. Yeah, there's never anything like that in FOL. Right? John, if it's an FOL name, picks out exactly one person, and then there has to be a different fucking name for the next John that comes along. They can be John subscript 2, right? We never, ever, ever have the same name for multiple objects. That doesn't happen. Our language is not going to allow for that. Every name picks out one object without any ambiguity. Now, notably, we might not know what object it is, but that has to do more with us. Right? This isn't about the epistemology. This is about the semantic content. The name is guaranteed to pick something out. We might not know exactly what it is, but we know it picks something out. And we don't have to worry about it applying to two different things. That said, we can have two FOL names for the same thing. I might, if I wanted to, have Socrates or Steve, and I'll introduce lowercase a and lowercase b to refer to Steve for my own weird personal reasons. There's no bar in having multiple names for one thing. But what you can never have is one name for multiple things. Okay. Similarly, we never have empty names. That is, if you have a name, it's guaranteed to refer to something. Now, this is in contrast with English, right? English seems to have lots of empty names. Right? I don't want to spoil anything and ruin people's childhoods, right? Santa Claus is an empty name. I know. Tears, right? Santa Claus as a name denotes nothing. Right? If we think about it as a proper name, it goes out into the world and tries to find the man who lives in the North Pole, da 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 da, and it fails. It's an empty name. FOL does not have any empty names. If there's a name, it's guaranteed to pick something out. That's just part of the way the language is set up. We just dictate that. Okay, now an FOL symbolization key is going to tell us what each FOL name we're interested in picks out, right? So it'll have things like lowercase a is Socrates, lowercase m is Mira, M1, also Mira, little n, Nathan. Yes?
As you said about the empty names, does it mean, like, for example, we cannot analyze a sentence like Robinson Crusoe get lost in ice?
We could, but if we do, what we have to do is treat Robinson Crusoe as denoting something, right? So Crusoe, for our purposes, would be something that's in our, we're going to use the term we'll talk about in a minute, have to be something in our domain. Now, whether that means he's out there, that's a different question. For our formal language purposes, if we use the name, he's got to be in our domain. Whether that means he's really out there, exists or something, we don't care about that right now. Good. Okay. Yes?
I'm also not entirely following the empty names for an exact definition of empty names.
So an empty name is a singular term, a proper name that fails to denote. So again, to go back, right? Think about a proper name. Proper name, the semantic function of a proper name is it basically just denotes an object. It specifies an object and refers to it. So an empty name is one that tries to do that but doesn't succeed. Right. Zeus. I figure that's a slightly less controversial one than some other religious examples we might invoke here. A really good example is Vulcan. Not Vulcan, the Greek god or the Roman god, but Vulcan was postulated to be a planet closer than Mercury to the sun. It was supposed to explain Mercury's movements. As it turns out, what was going on there was the light was actually bending around the sun because of how heavy it is gravitationally. Vulcan was postulated, and there was lots of speculation about what it would look like as a planet and blah, blah, blah. Turns out all of that was wrong. So Vulcan is an empty name. It doesn't denote anything. Right? But it's still a name. It functions like a proper name. It just fails to actually get to anything. Right? Does that make sense?
Yes. So, just for example, would talking about Heracles, would that be a proper name with meaning, or would that also be an empty name?
So we want to be careful here, and there's a slide between whether the name has meaning and whether it has reference. Right? This is something we're going to talk about in the second half of the course. All that we're really concerned with is, does it pick something out? Set aside the question of what it means. Right? An empty name fails to pick something out. So Hercules probably does not pick anything out. Right? It's empty in that sense. Does it have meaning? We'll come back to that. Right? But that's the important idea, right? Whatever the meaning of a proper name is, its function is to denote, to refer. And if it fails to do that, if it reaches out into the world and fails to find anything, it is empty. FOL names are never like that. They always reach out and touch something. Okay, cool. Okay, so those are names. They get us to things. They refer to things. Variables. Variables are, as the name suggests, variables. Did people do algebra? Did people study algebra back in school? Right? Do you remember, like, you would have a thing and it says, find the value of x. Right? You've done that sort of thing. X was a variable, right? You were looking to see what could you replace x with. That's basically what variables are in FOL. Right? We express variables with lowercase s through z. We can use subscripts if we need them. And they function a little bit like pronouns in the sense that they give us a way to indicate gaps. Right? They're like, oh, it is human. Cool. Who's the it? What does it denote? A way you can kind of get it is if you look at this. X loves Y, but Y doesn't love X. The X is here. It's the same variable. It's telling us, hey, whoever you plug in for the X, you plug it in for both spots. And the same for the Y. It's a different variable, but whatever you plug in for this Y, you need to plug in the same one there. So variables give us a way to kind of indicate, like, if this says A is an H, this tells us is an H, where is going to be filled in a moment. And the trick is going to be that in order to make this work, to make the variable work, to say how we replace the variable, we're going to need to plug in one of our quantifiers. That's the basic thought though. But this is our fundamental unit. Predicate and a term. This says A is an H. This tells us there's something you can plug in here, maybe everything you can plug in here, replacing X with, that's going to be an H. Now what this means is that when we're constructing an FOL symbolization key, we don't need to say what a variable stands for, because that's a mistake. Variables don't stand for anything. They're fucking variables, right? They should be replaced. In another sense, a variable stands for no entity or every entity. Right? It's just a way to label gaps. Okay. As we go along, I think this kind of concept will fill in a little better. Right? But again, the core idea here is hopefully clear. It's a variable. Right? It's something that we can replace with various different replacements. Okay. Now, the last key constitutive part are predicates. Right? Predicates, in more general terms, are parts of language that do things like ascribe properties. Right? So, is in the logic class, or a dog slobbered on, or is in Tilburg, or all predicates. But you note, in these cases, right, the predicate has a gap. It's is in the logic class. Or a dog slobbered on, we have to fill in that gap. And we fill in that gap with a term. More generally, when we think about sentence construction, and this is true in English and eventually in our FOL, predicates link up with singular terms to give us a sentence. We take the proper name Socrates, we take the predicate is human, we jam them together, and we get Socrates is human. Or we take the predicate a dog slobbered on, and we take the proper name Nathan, and we get a dog slobbered on Nathan. So again, this already tells us our sentence, our base sentence, is a predicate and a term. And we'll symbolize predicates and FOL using capital letters with subscripts if we need. So we'll write it like this, right? Predicate H says blank is human. Predicate T says blank woke up at 3:30. Predicate T1 says blank is a terminator, where whatever term we attach here is the thing that we're plugging into the blank. Right? Okay, before we trundle on, questions on names, variables, or predicates? Yes?
As you said about variables, in this case, for example, T, the one is not a variable.
That's just a subscript for my predicate, right?
If it was like H and X, for example,
Then we're plugging in the X to whatever is here. But of course, plugging in the X is really just a way for us to kind of say, it is human. Oh, cool, what's the it? We need to go on and say some more. So, some examples might help us a little bit here. We can begin to, yes?
Based on your definition for definite description, they pick out specific entities via description that only they satisfy.
Yeah.
So in the case of FOL, what about objects that have two FOL names?
Good, that's fine, right? So multiple names for one object is totally okay. What would be bad is if we had some definite description, purported definite description, that multiple things satisfied. Right? To go back again, remember, a definite description is supposed to pick out one and only one entity. If it turns out it picks out more than one, it ain't doing its job.
So each of the FOL names are definite description of the thing.
FOL names are proper names. They are not definite descriptions. They contain nothing about describing the individuals. Right? They function like English proper names. Proper names. They do this. They pick out an entity. They tell us nothing about what they're like. The way we talk about what they're like is by attaching that name to predicates. Right? The predicates are the ways that we say how things are. Predicates are the ways that express ways things are. Names just get us to things. That's it. That's it. They're just tags. Good. Okay. So, again, we can kind of start to get a grip on sentence construction by thinking about some really basics. So here's a sample proto FOL symbolization key. We've got some names and we've got some predicates, right? And we can start to stick them together. So using this, right, I can stick HA and get a way to symbolize Socrates as human. I can get HX, and this tells me X is human, but note X isn't a name here, it's a variable. More on this in a second. But I can have something like TM, Mira woke up at 3:30, and I can have TM conjunction TN. Mira and Nathan woke up at 3:30. So this is already suggesting familiar stuff about how to use the connectives. She always needs to go to the bathroom. Yeah, that's how it is. Okay. So let's do some practice, right? So our same sample key, let's try Mira woke up at 3:30. How would we symbolize that? TM, capital T, lowercase m. Yeah? Easy peasy. Socrates is the Terminator. T1A. Dun 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 dun. Nathan and Socrates are human. Yeah, right? HM, so we can paraphrase this as Nathan is human and Socrates is human. Remember all the stuff we did with TFL, right? And so Nathan is human, HN, conjunction, HA. And then finally, if Mira woke up at 3:30, then Nathan woke up at 3:30. How would we do this one? Well, again, let's use what we've learned before, right? The main operator of this sentence, what do we think it's going to be? It's a conditional, right? And our antecedents, Mira woke up at 3:30. We know how to do that. TN. Right? Nice. Okay, so honest to God, this is it, right? Basically, everything we're going to do is stemming from this idea. Right? And, well, it's going to get harder. But this is the basic idea, right? Instead of what used to be just capital letters, now it's always capital and lowercase letter. But everything we learned about how to do these sentences when it was TFL, same shit's going to work. Just instead of a capital letter, it's always capital and lowercase, at least. Okay. Now, let's talk about quantifiers. Oh, there's a typo there. That's terrible. All right. Now, I've already suggested and done a little dancing around variables don't work exactly like names. And the way they don't work exactly like names has to do with the interplay with quantifiers. So, our quantifiers, we have two. The first one that we'll talk about is the inverted A, the upside down A. It is the universal quantifier. The first thing to note about both of the quantifiers is that you will never see it by itself. If you have one of the operators, it will immediately be followed by a variable. I'll say that again. Whenever you see a quantifier, it should always be immediately followed by a variable. That's the variable that is bound by that quantifier. So the upside down A, x, tells us that for all x, every x. So for example, this universal x, hx, tells us everything's an h. And this tells us for all y, ty, everything's a t. And this tells us everything's an f. So again, what's important is that whenever you have a whenever you have a quantifier, it will always, 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 always be immediately followed by a variable. That is the one it's controlling. And the function of this universal quantifier is to tell us that you can replace the associated variable with any name you like, and it should still be true. So for example, if we have universal x, hx, it's telling us, cool, if you replace the x with a, you get something that's true. And if you replace it with b, you get something that's true. And if you replace it with c, and d, and e, and so on, 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 and so on. Effectively, the universal is like a big and. HA and HB and HC and HD and da 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 for every name you can think of. And this is true if we think about more complex sentences, right? So for example, this just tells us, hey, no matter what name you plug in for y, the resulting bracket sentence is going to be true. So this is true for A, this is true for B, this is true for C. All of them are true. The universal, again, tells us replace the associated variable with anyone. And I'm still true. Everyone makes the attached sentence true. That's the universal. It's the upside down A. Okay. The next one, our second one, our other quantifier, is the backward Z, the existential. And just like with the universal, whenever you see a quantifier, it will always be immediately followed by a variable. That is the variable that is attached to it, that it controls, that is bound to it. And the existential is a way to say for some, or at least one. So this tells us something is an H, something is an F, something is a T. And again, the function of our existential, so remember the universal, the function was replace the associated variable with any name and you get something that's true. The existential says there's at least one name you can replace the associated variable with and get a sentence that's true. So effectively, the existential is like an OR. If you have existential x hx, it's telling us that either HA or HB or HC or HD or E, or you keep going. At least one of these is true, maybe more, but at least one's true. And just like before, doesn't matter if it's a simple or if it's a complex, right? The general idea for the existential is the same. It's just saying you can replace the associated variable with some name, and the sentence is going to be true. Okay? So if universal says replace the associated variable with every name, existential says there's at least one name, some name. We'll make it work. Okay. So, to bring it back to this, the simplest form of FOL sentence is a predicate and a name. The next simplest form is a predicate and a variable attached to one of our quantifiers. So it will either be for all x, hx, or existential x, hx. You could never get just this, never just h with the variable, because you don't know how you're supposed to replace the variable. The quantifier tells you, hey, to go back a slide, is it with anything you like? Or is there maybe just one particular thing that does the job here? So again, this is a basic unit, but we need some more machinery on top to tell us how to understand what this is trying to tell us. Okay. Now, before we go on, you can pause, ask, what questions do you have for me on these quantifiers? I know, yes, please.
In the last sentence you wrote,
Yes.
opposite qualifier is also in the sentence. Why is that?
Yeah, good. Just to kind of indicate that basically when we're thinking about this quantifier, it's telling us this thing in the bracket, right? You can find some way to replace this to make this sentence in the bracket true. Now, of course, doing that might involve paying attention to other quantifiers too, but I just wanted to indicate no matter if it's simple or if it's complex, operation's the same. Much like with the previous slide, same thing. That's all I was after there.
Can it be also that it's the same qualifier in a sentence?
Yep. Yep. I mean, this would be fine if this was an existential in the front instead of universal, right? Just then, instead of the ands, we'd have ors. Cool. Okay. Now, one thing with these quantifiers, it'll be a little bit easier to understand them as we start to get into some examples and kind of do some work on them. It's very hard right off the bat to get it as this very abstract way of talking about it. But I think it's useful to get the kind of general thought and then come back and think about specific examples. Right? So maybe we can help ourselves a little bit by thinking through a few things. We've given the same, so this is the same sample symbolization key we had before. Right? So let's think about how would we say using this key, everyone is human.
The with this junction with the line through it, an X, and then between. Do you have to do between brackets?
Brackets or no is fine. Either way is okay with me.
And then HX.
Perfect, right? So universal quantifier x, hx. Note, we could have used y here. We could have used z. We could have used any letter we like between s and z. I don't care. This tells us everything is an h. Everything's an h. Okay. How would we do someone's human?
Same that the other one, but existential.
Yeah, we want to use our existential, right? Existential x, hx. Something is an h. Something's an h. Now that could be true if everything is, but this just tells us at least one is. Everybody's in the room. Somebody's in the room. Right? Okay. How would I say there's a human and Mira woke up at 3:30?
The existential quantifier x, hx, and a conjunction, and then t.
Yeah. Right? So we know how to do this. We've done it twice now, right? That's Tn. And we know how to do and, that's our conjunction. And then it's just, there's human. We got it up with our bow already. Existential X, that should be an M. This is still a typo from back when this was about my old dog, Yelka. That's sad. I keep forgetting to fix it. And then our last one. If Socrates is a Terminator, then everyone is. If Socrates is a Terminator, then everyone's a Terminator. Yeah.
I put for all y bracket T1A conditional T1y.
Yeah, that's fine. So we can, an interesting one here is you can either have just the quantifier scoped only in the consequent, or put it in the front and have it the whole thing. But importantly, right, if we read it just flatly as it's written, we can read it as, right, it's an if-then, so it's a conditional, and our antecedent is Socrates is a Terminator, and our consequent is everyone is a Terminator. So there we go. Okay. How are we feeling with these ones so far? Okay? Sorry, yeah, I couldn't tell if that was a...
Also, rewrite the third one and the same way rewrite the fourth one.
Yes. So we could put brackets and have that on the outside, and it would be perfectly fine. Yes?
Do you need to be consistent with variables you use with one synchronization key?
No. So the nice thing is you could use X here and Z here and Y here. Don't matter at all. All that matters is you need to be consistent in the sentence that you're writing, right? Because, again, the variables don't stand for anything in particular. All that matters is that they're attached to the right quantifier and they go across. That's all. Good. We feeling okay about these ones so far? Relatively. That's all we're looking for. That's all we're looking for. Okay, I want to talk about two more things, then we'll get to our break, okay? So, because I know, again, I'm still thinking with a lot of stuff, this is kind of weird. So here's the one. If someone is a Terminator, then everyone is. Now, one way we might go, and this kind of comes to the suggestion we just had, right, is we could have the quantifier in the back and drag it to the front. That's perfectly fine. So you might be tempted to symbolize this one like this. And that's fine. This tells us if there's someone that's a Terminator, if there's something that is a T1, then everything is a T1. But suppose you kicked this up to the front. That is, if you had the universal in the front. Like that. Well, it's written in red. You know what that means. That ain't good. This is a problem. Why is this a problem? It's not quite a contradiction, but there's something weird about it, right? So what's weird about it is kind of coming back to what we were saying earlier, right? If you think about the variables, they're always attached to quantifiers. So let's take that one, that variable right there. Which one is that one attached to? Which variable, which quantifier is controlling this variable? Yeah, but that one is too, right? This one could be attached to it, or this one could be. We don't know which one it's supposed to be. So the problem that we have here is something we call a clash of variables. A single variable cannot serve two masters at once. Right? You cannot serve God and mammon. That is, if we look at that first one, our X is governed by both the universal and the existential. And that's bad, because we don't know which function we're supposed to be understanding it as. Is it everyone can be slotted in here, or is there just at least one thing we can slot in here? And the problem is the fact that we've used X in both cases. Right? So the solution isn't to just like, oh, this is all just rubbish, right? Is that we need to be careful about how we attach variables to the quantifiers. we can make this work if we just change the variable attached to either our universal or our existential. Something like this. Okay. Now, the only difference that we made here was we made it clear that the universal is linked up with the variable y. So now as we're reading our sentence and we come across the x, we know that the only quantifier it could be linked up to is the existential. Unlike here, where we didn't know which one it was connected to. And the same thing for the y. There's no confusion because the only instance that the variable y appears is linked up with this quantifier, with the universal quantifier. So our top sentence was okay. Our top sentence was okay because the scope of each quantifier was restricted. This quantifier is just the antecedent. This quantifier is just the consequent. But as soon as we had the scope of this one be the whole damn conditional, we had our clash. Yes?
But then the x and y can be the same.
Yes, so nothing prevents us plugging in the same objects. But importantly, they are different variables. That is, they're attached to different replacement functions. That's the important thing, right? So this is grammatically problematic. That was the issue. Not, oh, what kind of things can you start slotting into the variables? That's all we're really concerned with here, right? Basically, we're just still getting the grammar before we start doing plugging in stuff. But yeah, good, nice. Okay. Make sense? Clash of variable point? Again, the key idea here is just this thought. No serving two masters at once. Okay. Now, the last thing I want to talk about before we take our break is beer. Right. So, this is something I worry about a lot. For example, this weekend, I was actually at a really terrible conference. But part of the conference involved a gig on Saturday night, and we stayed at the place the gig was at until the very end, and they actually kicked us out, not because it was closing time, but because they had run out of beer. And the lady behind the bar, this is genuinely true, the lady behind the bar did say something like this. She said, all the beer is gone, right? And that was a tragedy, right? It was an absolute tragedy. But importantly, it was not the tragedy that there is no beer in the world. That would have been beyond tragedy, right? That would have been apocalyptic. Clearly, she just meant there's no beer here. We don't have any beer to sell you, right? Which was great. We just left and went to the bar next door. Got beer there. So when someone says, oh, the beer is gone, why do we not read them as saying no beer in the world? Well, there's something like implicit context restriction, right? Context is basically restricting it to here, or the stuff that we have to sell. Everyone's here. Really? This room doesn't look big enough to fit all 8 billion of us. And we all look a lot smaller than I expected. Right? No, clearly everyone here is meant to be picking out some kind of contextually restricted. Everyone registered for the class. Context can do the job, but FOL don't play nice with context. So we don't allow for implicit restrictions. First order logic requires that you make this explicitly. And the way we do it isn't via context, but via specifying domains. So whenever we have an FOL symbolization key, it must tell us a domain. And domain is the collection of things that we want to talk about. Right? So the domain might be things in the fridge, if we're saying all the beer is gone. It might be physical objects, if we want to say, right, everything is caused by something. Or it might be universal, if we want to say everything is a physical object. If we're materialists, say. Importantly, whenever we're doing a symbolization key for FOL, you should specify a domain. If it doesn't specify a domain, well, something's gone wrong. Read it as universal. Yes?
So the main doesn't like a symbol. There's no symbolization.
There's no symbolization. This is something that's true in the symbolization key, right? It's not going to be part of our actual FOL language. It's helping us understand the language, knowing what the symbols are talking about. But it's not part of the language itself. Now, the reason we want a domain is this is the sort of thing that our quantifiers are going to range over. And what I mean by that is, right, when I say everything is human, that is for all x, hx, what I really mean is everything in the domain is an h. That is, no matter what you pick from the domain, it will be an h. Oh, cool. I've grabbed Steve. Well, that's fine. Steve wasn't in the domain. It doesn't matter that he's not human. Similarly, the existential tells us there's at least one thing in the domain that satisfies our sentence. So domains are very useful. They basically allow us to say, these are the things we're talking about. Now we have some restrictions about domains. The first restriction is that the minimum domain has at least one object. Doesn't matter which one it is, right? But there's always at least one thing. So we have one minimum domain that's just Steve. We have one minimum domain that's just me, one minimum domain that's just you, and so on for every individual object by itself. Importantly, we can never have what we call an empty domain. That is a domain that's got nothing. No, that's just restricted. We block that from our language. We're not going to allow for that sort of thing. You're always talking about at least one thing. Similarly, we've already mentioned, right? Names always pick something out. But of course, what that really means is that every name that you're using has to pick something out from your domain. So again, we can never have empty names. Together, and the reason why we do this is it lets us make a very sensible inference. That is, we can go from a sentence featuring a name to a sentence with an existential. If we know that N is a T, then we know that something is a T. We know that N lives in the North Pole and wears a red suit. Well, then something lives in the North Pole and wears a red suit. This is a very useful inference to have. We'll talk a little bit about what happens if you let that go in the second half of the course. But you have to have these two assumptions in order to be able to make this kind of inference. So, again, a domain must have at least one member, and every name must pick out exactly one member of the domain. But of course, a member of a domain may be picked out by one, many, or no names. Okay. To get a grip on when we have, yes, sorry.
Yeah, what is the domain? Are we in this sentence?
Can be anything you want, right? It's just a collection of things you're talking about. So if I wanted to talk about the people registered for the logic class, right, that could be my domain. Or I could talk about all of the students in Tilburg University. Or I could talk about all of the grains of sand that are on such and such beach. Right? Or only even numbers. Or everything. Everything. So whatever your domain is literally just whatever you're talking about. And you have to make it explicit. You state it outright. We do not allow for it to be implicit. That's the important thing. And when we're building FOL symbolization keys, the minimum domain is one object. Which one it is, we don't really care. But you have to have at least one thing. Okay. Cool? Questions before we go on? Again, I realize this is heavy, but I hope people are feeling kind of okay about it so far. Okay, so let's take a break. It's 46 now, so why don't we come back in 10 minutes? Is that okay? 56? Yes.
Go back on slides.
Yeah, sure, no problem. So yeah, come back 56 and we'll do the rest. Sounds good?